Welcome back to Big Picture Technology and Science. Yes, I've grown a beard since the first video. Not sure I'm gonna keep it, so don't get too attached. This is going to be the second video in the series The Way Electricity Changed Our World. Last time we talked about energy distribution, and this time telecommunications. The need to communicate remotely is as old as mankind. Humans used almost any means that could be generated in one place and detected in another to telecommunicate. Audible signals such as drums were probably the first telecommunication signals, but fire and smoke signals followed. Later, lamps and flags were also used. And then electricity came and changed everything. In this video, we'll try to understand how electricity revolutionized telecommunications.
So what do we need for a telecommunication system to work? Basically, there are four elements required. We need a signal to be generated in one place. We need it to be delivered to another place. We need a way to detect the signal when it arrives. And finally, the signal has to have a meaning that the other side would be able to understand. That's about it. Can electricity create a revolution here the same way it did for energy distribution? Well, some of the characteristics that were known in the very early 19th century suggested that this might be the case. It moved quickly from one place to the other, and it stayed confined to conductors. We could therefore decide exactly where it will flow. We were also getting better and better at generating it now that we had Alesandro Volta's voltaic pile, which was actually the first battery. We could not only generate it manually, but we could have it available on every desktop. You can see Volta's voltaic pile in the picture here. It doesn't look very convenient, but definitely does the job. The big question soon became, can we detect electricity well enough, even small amounts of electric energy after it flows through long electric wires? As we said, detection was a key factor if electricity was to become our main way for transporting signals and for telecommunicating. If it was fire or lamps, you had to have someone on the watchout to detect those signals and interpret them. If you wanted to send electric current as your signal, you had to be able to detect this current, and it wasn't such a simple task, at least not in the early 1800s. It is hard to imagine, but early electric-based communication systems used acid tubes for detection. The passing current would generate bubbles that could be detected, but this method was not practical. William Sturgeon's electromagnet was about to start a revolution. The electromagnet is a coil of wire that shows magnetic features when conducting electricity. Once introduced, it enabled new and innovative detection devices. At first, a simple compass needle was used to detect the flowing current, as you could see in my very simple demo. At about the same time, the mirror galvanometer was invented and was able to detect very small amounts of current by magnetically moving a mirror that deflected light. The use of magnetic needles was very common, and they were first detected by human beings that had to be on the watch, but later electromagnetic moving levers were used to create ink markings on long moving strips of paper, as you can see in the video below. The next big step, and a revolutionary one, was the electric relay in 1835, and it is attributed to Joseph Henry, an American scientist who developed the electromagnet into a practical device that by moving a small lever can close another separate electrical circuit. This opened a whole new range of detection devices that could not only detect but also perform an action upon detection. It's hard to imagine how such a small and simple device, as you can see in the video below, could create such a big impact on telecommunications. As we described, electricity's detection methods evolved during the 1800s. The communication systems that relied on these detection methods evolved alongside, and their use gradually expanded. It was the Cooke-Wheatstone telegraph that has become the first system to be put into commercial use in 1835. It was used for railroad signaling at first. The receiver consisted of a number of needles which could be moved by electromagnetic coils to point to letters on the board. The number of wires used was equal to the number of needles, and not all letters were supported. This system has received good publicity in 1845 in England when used to help arrest the infamous murderer John Towell by signaling ahead to the Paddington station after he boarded the train to London. You can see this system on the uppermost picture here on the right. Communicating between continents was the next great challenge. We have to understand that when it came to very long distances, messages were sent just like any other commodity at that time by ships, and took weeks to arrive. The first attempt at transatlantic telecommunication occurred in 1858, but it was not until 1866 that a functional telegraph cable was permanently laid between Europe and North America. It is hard for us to imagine today this heroic achievement, but it seems that this was really made out of the stuff that makes epic Hollywood movies today. Just try to imagine special ships being built to carry the huge cable over more than 2,000 miles, laying it at the depth of sometimes 2 miles on the bottom of the ocean. Here in the picture, you can see the Great Eastern steamship being converted to lay the cable. Imagine cables being torn and lost at sea, attempt after attempt, and ships sent to look for the sunken lines, money being grazed again and again and again. And once the line was laid, just try to imagine 2 engineers at the 2 ends of the line trying to solve communication problems when the only way of communication is the line itself, at a time when ships took weeks to cross the Atlantic. Once the cable was laid and problems solved, telegraph messages took only a few minutes. It's interesting to note that the main hero behind this achievement is not an engineer or a scientist, but an American entrepreneur named Cyrus Westfield. The next big step was taken only at the beginning of the 20th century. As the distances kept growing and the need for telecommunication became stronger, both for commercial and military uses, the reliance on long wires for telegraphy became somewhat limiting. How can you communicate with every remote island or with ships at sea? What makes wireless communication especially interesting is the fact that, unlike previous discoveries that we talked about, this discovery was led by the mathematical models of a great Scottish mathematical physicist named James Clerk Maxwell, who predicted the existence of electromagnetic wave based on his mathematical models, the Maxwell equations, a model that led other great scientists like Heinrich Hertz and Oliver Lodge to prove that these waves actually existed, and for men like Guglielmo Marconi to develop a working wireless telegraph system that relies on these waves.
It should be noted that wireless telecommunication required different and more sensitive detection methods than the ones we talked about. Marconi, that was aware of his own limitations, recruited the close assistance of a university professor named John Ambrose Fleming, whose contribution to the development of this system included the invention of the Fleming valve, the first vacuum tube diode that was later followed by the important development of the triode, the first electronic amplifier by Lee DeForest in the US. These devices enabled wireless electromagnetic waves detection by both amplifying and rectifying them. And so you have it, the long way from drums and smoke to wireless telecommunication, and the major role that electricity and our understanding of the electromagnetic waves played in this revolution. This was the second video in a series of 4 describing the way electricity changed our world. If you haven't seen the first one, click the link below, and if you want to be notified of my next videos, subscribe using the button on the left.